Hello, this is Lab 7, Exercise 1. This one asks us to derive the gain of the non-inverting amplifier circuit. So we perform KCL at node 1 and find that the gain equals V out over V in, which equals 1 plus R2 over R1. All right, so for exercise 2, we're going to be looking into our circuit here real quick. We got this potentiometer, which controls V in for our op amp here. We have the green wires, which represent V minus. We have the yellow wire, which is reading V plus. The blue wires, which are reading V out, which actually equals V minus. And then we have the white wire here, which is actually gray because I ran out of white wires, but the white wire is reading V in. We have our 4 analog inputs here, and each of them is reading those voltages respectively. All right, so now we're going to look into our Arduino code real quick. We have our baud rate set here. We have our 4 analog pins set to be inputs. And then the loop, we have Vn being read by A0, V negative being read by A1, V out being read by A2, and V positive being read by A3. And then the Arduino code has a string of values here. Just to, before I did the processing, I just wanted to make sure it worked. And then the delay 50 means it's just me taking the data points at 50 millisecond intervals. And real quick, I know I didn't have to do this, but I'm going to dissect the processing code just a little bit here. This is all just stuff that has to be in the processing code from Lab 5. And then the only things I changed, again, had the lines set here for the axes. The only thing I changed were the table values for Vn, V minus, V out, and V plus. And then our labels are the same, 0, 1, 2, 3, 4, 5, respectively. The legend's a little different, so we set Vn to be white, V minus to be green, V out to be blue, and V plus to be yellow. And then we have the V in, V out, V minus, and V plus here in the legend. And then the actual plotting of the points here. And then this sets the boundary basically, so that way when it gets to the end of the screen, it bounces back and constantly repeats. All right, and this is our processing output here. So when I turn the potentiometer, you can see it's going to affect the white line, which is our V in. And then when I get above 2 volts, the op amp takes over and amplifies V out. And then you can see when I go back below 2 volts, it goes back to just whatever V in is. So basically V out past 2 volts equals V in, but below it, V out is always 2 volts. All right, so now we're going to be looking at the circuit for exercise 3. We have this potentiometer, which is supplying our V in, goes straight through the resistor and then straight into V minus. From V minus, it goes out and then through another resistor, which then goes straight to V out here. And then for V plus, we need it to be exactly 2.5 volts. So we used 2 resistors here as a voltage divider. And then this yellow wire is reading that, and it maintains 2.5 volts. If we look at our processing output here, we'll see the white line is V in and the green line is V minus. And as we turn the potentiometer and change it, we get to that yellow line which is V plus, which is steady state at about 2.5 volts. And when we cross that line, the blue line, V out, inverts by a certain gain factor, which is -10 for this case. All right, and down here we have exercise 4, where we can see our diagram here. We know impedance equals 1 over J omega C. Performing KCL, we get that V out equals -1 over RC times the integral of Vn of t dt. All right, so finally, we're just going to analyze our circuit here for exercise 4. We have the V in being supplied by the potentiometer, going straight through the resistor, and then going into V minus, and then from V minus going out through the capacitor and into V out. And then V plus is just grounded, and all the pins here are the same. Now, I just wanted to note that for exercises 3 and 4, I used the same processing in Arduino codes as 2 because nothing changed between the exercises for that. For the integrating amplifier here, you'll see that before it inverts, nothing changes when I change V minus and V in. But as soon as it inverts, you'll see a large jump. And then you'll see that up top, since it's with respect to time, V out is changing with V in and V minus. And then when it flips again, it's at steady state at 2 volts.